Okay. Yesterday, we started talking about special types of parallelograms. Those special types of parallelograms included rectangles, rhombi, and squares. Now, yesterday we focused in on the rectangle piece. We talked about one theorem related to rectangles, and then we did a bunch of solving with it. Now, as we did that, I reminded you, and we used, if it is a rectangle, that means it's a parallelogram, so it holds all of those parallelograms theorems as well. So, as we were working with our rectangles, we still used all of this stuff. Today we're working with rhombi and squares. Since rhombi and squares are also parallelograms, they also are going to use these theorems. But they do have some of their own. Specifically, there's two related to rhombi. First is the rhombus diagonal theorem that says a parallelogram is a rhombus if and only if its diagonals are perpendicular. What does it mean to have perpendicular diagonals? They cross, more specifically, in what way? Because like this is not perpendicular. Perpendicular requires it looking like this. They cross, and when they do, they form a specific kind of angle. A right angle. So, ABCD is a rhombus if and only if. Now, the key thing, the actual theorem itself says AD is perpendicular to CB. That means these diagonals are perpendicular. The key thing that you're going to need, though, is that it forms a right angle. In other words, this right here is a right angle. Now, I've mentioned this before, and I'm going to mention this again. If this is a right angle, what do you know about these three angles? They're all right angles. In all technicality, all of these are right angles. If you want to put the little markings on all of them, you can. Notice I make them different sizes so that I can tell that I didn't just draw a square in the middle. Okay? We also have the rhombus opposite angles theorem that states a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. What does bisect mean? Cuts it in half, cuts it into two congruent parts. So now my diagonals go through and they cut the angles in the corner in half. But there's something else we need to know with that. So before I write on my paper, I'm going to write on the active board. If I write it on the active board, you do not want to write this down. We'll get to what we write down. So if it bisects the angles, what that technically means is this angle is congruent to this one. This one is congruent to this one. This one is congruent to this one. And this one is congruent to this one. A lot of little congruencies. Again, if I write it on the active board, do not write it down. But we can use something else to get us what we want here. Something that simplifies this fact down a little bit. I'm going to have to move my sheet back there, but we'll get there. Pull it together. We got things to get through. A rhombus is a parallelogram. That means its opposite angles were already congruent. And if the opposite angles were congruent, and then the angles got bisected, we actually know a more simple version of this. Because, for example, if this angle right here, let's just say that angle was 100 degrees. If it got cut in half, what does that mean about those two little ones? You cut 100 in half, what do you get? 50. That means each of these would have had to have been 50. But with our parallelogram opposite angles theorem, this angle would have also had to have been 100. And when you cut it in half, its two halves would have been 50. Would you agree that all four of these are the same then? They're all 50. That is true for every single rhombus, regardless of what the number is. So here's what we're actually writing now. In our picture, this little angle is congruent to this little angle, is congruent to this little angle, is congruent to this little angle. All four of those angles end up being congruent. It's also true with the other diagonal, but they're a different congruence. So I'm going to do the double congruent marks for this one. So, in all technicality, the theorem says AD bisects angle A and angle C. Technically, I should be using the three-letter names there for the sake of the fact that mainly the thing you're going to use is the picture. I'm just going to call it A and C for simplicity. BC also bisects BC bisects B and C. I've got this brought backwards. That's a D, that's a C, my bad. But the main thing you're going to use on this one is the picture with those markings. Remember the other day where I mentioned you should be writing down these markings? Or something I've noticed is people not doing the markings on their notes. Put the markings on. This one, you're mainly going to use those markings more than anything else when it comes to working with angles. So, one of the things you're going to see today is you're going to see problems similar to that last one from yesterday's homework assignment. But they're going to be with rhombi, or rhombus, if you want the singular. But these two theorems make these problems a lot easier. So, find the measure of the numbered angles given ABCD is a rhombus. Okay, if ABCD is a rhombus, here are the things I know about angles. First off, I know that the diagonals crossing one another make a right angle. Does that help me solve any of my numbered angles?
Yeah.
Which one?
90.
Measure of angle 1 has to be equal to 90. Because these have to be right angles in the middle. The other thing I know is that the diagonals cut the corners in halves and opposite corners were the same in the first place. So this is congruent to this, is congruent to this, is congruent to this. And this is congruent to this, is congruent to this, is congruent to this. (61) is the only other angle that was given as a number. Which angles are also 61 degrees according to the markings we just put on there. 2 and 3. Measure of angle 2 is equal to 61. Measure of angle 3 is equal to 61. The only angle left we have is angle 4. What do you think we can use to find angle 4? We don't know anything else about rhombi angles, so we're going to use something else. We're going to use triangles. Angle 4 is hanging out in this triangle right here. What do you know about angles of a triangle? They add up to 180. So that means angle 1, angle 3, and angle 4 added together equals 90. What is angle 1? 90. What is angle 3? Angle 4, we don't know, so we can put an X there if you prefer, equals 180. Angles of a triangle add up to 180. So if I take 180 and take away the 90 and take away the 61, that'll give me the measure of angle 4. Those two together is 151. I could have subtracted them separately, or I could subtract them together. 180 minus 151 is 29. That was the measure of angle 4 that we were solving for. So it's similar to the last problem from yesterday's homework assignment, but rhombi tend to be easier because of these new theorems. Okay, rhombi. Also a rhombus. How do I know that? The instructions told me so. There are markings that we can add to rhombi to work with their angles. Haley, Hurt. What is one thing we know about the angles in this rhombus? Which ones? For example, like the 38 would be congruent to which other ones could I mark? Angle 1, as well as the one next to angle 1 and the next to it. Now neither of those have anything on them, so angle 1 is the important one. Measure of angle 1 is 38. Jasmine, what else do we know about angles in a rhombus? The other ones also have the congruencies. So I know when I find angle 2, it's going to be the same as whatever angle 4 is. Cam, what's the other marking that we put inside the rhombi for angles? We did all of these. Have we done these? What are those symbols? We have right angles where the diagonals intersect. Piper, do we know either 2 or 4 or 3 right now? Beautiful. How are we going to find 2 and 4? What are we going to use? Ava, thoughts on what we can use? Yep. Yep. What did we do on the first one?
Oh, triangle.
We used a triangle. We got a bunch of triangles here. We can use a triangle. Any of these triangles will do. Because angles of a triangle still add up to what again? 180. In this triangle, I've got a right angle, that's 90, plus, that angle's not marked, but do I know its measurement? It's 38. Plus, angle 2 I don't know, and if I don't know it, and there's no variables already being used, I could just call it x equals 180. Combine those, I get 128 plus x equals 180. Subtract 128, and x is 52. What was I actually solving for? Angle 2. Jada, what's the measure of angle 4 then? Yep. It's also 52, because it has to be congruent. So, next problem changes it up a little bit. It says, in a square, wxyz, wy equals 4x minus 15, and xz equals 3x plus 8. Do we have any theorems specific to squares? Is there a square diagonal theorem? Or a square opposite angles theorem? Or any square theorems?
I don't think so.
Oh. We didn't talk about a single theorem about a square. So the question is, how am I supposed to deal with this? We did yesterday, though, talk about what a square is by definition. By definition, a square is a parallelogram that is both a rhombus and a rectangle. So, if squares are both rhombi and rectangles, that means we can use the rectangle, the rhombi, and still the parallelogram theorems. All of them apply when you're working with a square. Okay. In square wxyz, the first thing I recommend you do is make sure you know what that picture looks like. Y'all know what squares look like. W, X, Y, Z. I'm given WY. Where is WY on this shape? Goes across. What's that thing called when it goes from corner to corner, not right next to it? WY is a diagonal. What about XZ? Also a diagonal. So, we're given diagonals of this square. So I want to focus in on what I know about diagonals of a square, which is what I know about diagonals of a rhombus or a rectangle. Do you have a question?
Did you go so I can take notes?
No. let you see the notes afterwards, but I'm not. We're continuing through this problem. So I'm going to focus in on what I know about rhombis and rectangles with their diagonals because a square is both of them. Now these are diagonal lengths, right? Right? That's an important thing to note. They're not angles. This theorem, did it tell us anything about diagonal lengths? No. How about this one? No. How about this one? AC congruent to BD. This is diagonal lengths. According to this, if it is a rectangle, its diagonals are congruent. Is a square a rectangle? Yes. Which means diagonals are congruent. What does congruent mean? Equal. 4x minus 15 is equal to 3x plus 8. And we solve. X minus 15 equals 8. Add 15. X equals 23. Is that what the question asked for? No, it said find the lengths of the diagonals. Now that I know x is 23, how can I find the diagonal lengths? Plug it back in. To the first one, to the second one, to both of them. Either of them, because they're going to be the same. Plug it back into either of those and then simplify, and it should give me both of them. I think this one's easier. 3 times 23 plus 8. 3 times 23 is 69 plus 8 is indeed 77. XZ equals 77. And if XZ is 77, WY is 77, because those are the diagonals. Part B, still working with that square. Sometimes it's easier to redraw, so we're not trying to overlap things. On this one, it probably wouldn't make much of a difference because we didn't really draw on the other one. But it might help me simplify down my problem. The question asks about the measure of angle YWZ. Now, again, just like I commented yesterday, I'm still seeing some people struggle with the 3-letter names. The middle letter's the pointy part, in other words, the vertex. So the vertex on this one is W. So this is the pointy part of the angle, and it's going to go towards Y. And it's going to go towards Z, which means it's this angle right here. Now we're focused in on angles. So we can use anything we know about angles of a square. What do we know about angles of a square? The same thing we know about angles of rectangles and rhombi and parallelograms. I know that the full corner is 90 degrees because it's a rectangle. I also know that the diagonal coming through the middle breaks these up into little congruent angles. This is congruent to this, is congruent to this, is congruent to this. Wait a second. If the full thing's 90 and these two are the same, doesn't that mean this angle is half of 90? What's half of 90? 45. Measure of angle YWZ equals 45. In fact, all of those little angles are 45, not only based on this diagonal, but the other diagonal going in would also have been the same thing. because those were also 90-degree angles that were cut in half. That's it for notes today. So, today, we did 7.4 day 2. Today is the 20th. Our homework's due on Friday. Friday's the 22nd. 7.4 worksheet 2. Just a reminder, make sure if you are missing a test or a quiz,